Find a domain on which f of x equals x minus 3 squared is 1 to 1 and non-decreasing. Then find the inverse of f restricted to that domain. Let's take a moment and think just about this original function. So if we think about this original function we were given of our toolkit functions, this is an example of a quadratic function. Having the minus 3 on the inside of that quadratic function has caused this quadratic, this U-shaped parabola, to be shifted to the right 3 units. So let's sketch a graph of what our toolkit function would look like if it was shifted to the right 3 units. So normally in our toolkit function, the vertex or the kind of the center of the U-shaped graph would be at the point 0, 0, but since we've moved to the right 3 units, it's now going to be at the point 3, 0. We'd normally have the point 1, 1, so that's going to shift 3 units. We'd normally have the point 4, 2, so that would shift 3 units. And then we can use some symmetry to fill in the other side. So this is a sketch of what the function f of x equals x minus 3 squared will look like. So when we think about one-to-one functions, we're looking for graphs that would pass our horizontal line test. So you can see if you were to draw in a horizontal line on this graph, it intersects our function in 2 places, which means that this graph is not one-to-one. So this is why it tells us that we're going to need to find a domain where it's 1 to 1 and non-decreasing. So we're going to restrict our domain and then use just a portion of this given function. So there's a couple ways that we could do this. If you think about cutting this parabola right down the middle through that vertex, you would have 2 half parabolas. We're going to take the one, just because it was specified for us, that is non-decreasing, so our increasing one. So you can imagine kind of chopping off the left-hand side of that graph, and we're just going to keep this right-hand side of the graph. So I'm going to include the vertex there at the point 3, 0, and then everything to the right from there. So my new restricted domain, normally a parabola would go from negative infinity to infinity for its domain. For this restricted domain, I'm only going to consider the part of the graph starting at 3 and going to the right from there. So the range for that portion of the graph goes from 0 to infinity. So we've taken our original function, we've cut our parabola in half and taken the vertex and everything on the right-hand side as our new restricted function. So now we want to take this function and find the inverse now that we have a one-to-one function for this half a parabola. So I'm going to think about my original function as y equals x minus 3 squared, and I'm thinking about this on the interval just from 3 to infinity. So I'm going to use my switch and solve strategy, rewriting this as x equals y minus 3 squared. So I've taken every ordered pair and switched the coordinates x and y, and now I want to solve for y. Since the variable that I'm solving for is inside of the parentheses, I'm going to go ahead and take the square root of both sides. Normally when we take the square root of both sides as a solving strategy, we would use a plus or minus in our equation on the left-hand side there. Because I'm taking just the increasing, that right-hand side of my function, I'm going to just use the plus, so I don't need to write it as a plus or minus. So I have the square root of x, the squared and the square cancel out, leaving just y minus 3. So adding 3, we get that y is equal to the square root of x plus 3, or in our inverse notation, f inverse is the square root of x plus 3. Because this is the inverse of our given function, the domain and the range have been switched, and so the domain for this function is going to go from 0 to infinity, and the range of this function goes from 3 to infinity. So you can see, comparing back to the domain and range of our restricted function we started with, these have been switched. Graphically, you can start to see the relationship between a function and its inverse if we look at these on the same graph. So we could use what we know about the toolkit functions to help us out here, but we can also just use some points from our original function. So if we think about some of the points that were on that half a parabola, we said that we had the point 3, 0, 4, 1, and 5, 4. So this was our original function, f of x. So if you take each of those order pairs and switch the x and the y, it will give you a point on your inverse function. So 3, 0 becomes 0, 3, 4, 1 becomes 1, 4, and 5, 4 becomes 4, 5. So by switching those points, we get this graph that we have here in green. But it also fits with what we know about our toolkit function. So the square root of x plus 3 is our toolkit function for the square root function. The plus 3 has shifted it up 3 units, which is exactly what we see when we take a look at this green graph. But the relationship between the original function and the inverse function is that each one of those ordered pairs, the x and the y, have been inverted or switched, and this has switched our domain and our range as well. So the switch and solve strategy is how we can find an inverse function when we start with a one-to-one function.